We build telescopes to see farther, to peer deeper into the cosmic ocean. The James Webb Space Telescope is not just another eye on the sky, it is a time machine. Its golden mirrors capture faint, ancient light that has traveled for billions of years to reach us. This light carries stories from the universe's infancy, a time we once thought was shrouded in darkness. But JWST is pulling back that cosmic veil, revealing a beginning far more spectacular and complex than we imagined. Instead of finding small, faint galaxies, JWST has discovered a bustling metropolis of star formation. Galaxies bigger, brighter, and more mature than our theories allowed. This machine is not just confirming our ideas, it's challenging them at every turn. To answer the question, where did we come from? JWST must detect the ancient infrared light from the universe's first objects. By capturing it, JWST lets us witness the birth of the first stars and galaxies, the cosmic dawn. In May 2025, JWST delivered its most stunning revelation yet. A galaxy so old, so distant, and so advanced, it forces us to rethink everything about the universe's start. This isn't just another data point, it's a revolution. The universe has been hiding its most spectacular secrets in plain sight, waiting for us to build an eye sharp enough to see them. With JWST, we're rewriting the first chapter of the universe's story. The cosmic storybook is open, and the plot twist is just beginning. Since the first humans looked up, we've asked, what are those lights? How big is the universe? How did it all begin? This curiosity drives science and exploration, pushing us to build better tools to see farther. The Big Bang Theory tells us our universe began 13.8 billion years ago, expanding and cooling from a hot, dense state. For hundreds of thousands of years, there were no stars, just a hot soup of particles. As the universe cooled, gravity pulled matter together, planting the seeds for the first stars and galaxies. Astronomers act like cosmic archaeologists, digging through time by looking at distant objects. The farther we look, the further back in time we see. JWST is the ultimate tool, designed to see light from over 13.5 billion years ago. By finding and studying these primordial galaxies, we trace our own cosmic ancestry. The formation of the first galaxies ended the cosmic dark ages and created the elements essential for life. In searching for our cosmic origins, we're looking for our home. Before JWST, our picture of the early universe was based on theory and limited observations. We believed the universe started simple, mostly hydrogen and helium, slowly forming small, faint protogalaxies. Our models predicted that true galaxies couldn't form until the universe was at least 500 million years old. We expected to find only tiny, disorganized clusters of stars, cosmic villages, not cities. The universe, we thought, took its time, building up complexity over hundreds of millions of years. Scientists believed the first stars were massive and short-lived, and it would take many generations to enrich the cosmos with heavier elements. JWST was designed to find these faint primitive structures. Finding even a handful would have confirmed our theories, but no one was prepared for what JWST would actually find. Instead of villages, it found bustling cities, galaxies far more advanced than expected. The old story was about to be torn apart. In the silent theater of space, JWST unveiled a new star, MOM-Z14, the mother of all early galaxies. MOM-Z14 existed when the universe was just 280 million years old, only 2% of its current age. It's the earliest and most distant galaxy ever seen, with a redshift of 14.44. This surpasses all previous records, forcing us to redraw the cosmic timeline. Finding MOM-Z14 is like discovering a fossil millions of years older than any other. The discovery required over 120 hours of telescope time and a little help from nature gravitational lensing by the massive cluster Abell-S 1063. This natural magnification made MOM-Z14 visible to us. The significance is staggering. A well-formed galaxy at 280 million years after the Big Bang is like finding a fully grown tree just days after planting the seed. Our previous models can't explain its existence. As astronomer Peter van Dokkum put it, this galaxy existed when the universe was about 280 million years old. Sharks have been around on Earth for longer. MOM-Z14 isn't just a new data point, it's a direct challenge to our understanding. The universe was in a hurry to get started. The cosmic clock was ticking much faster than we thought. MOMZ-14's age is astonishing, but its brilliance is even more shocking. According to old theories, a galaxy this young should be small and dim. Instead, MOMZ-14 is exceptionally luminous, forming stars at a furious rate, a cosmic baby boom. Despite its brightness, it's compact, just 240 light-years across, over 400 times smaller than the Milky Way. Yet its mass rivals the Small Magellanic Cloud. It's a tiny galaxy shining like a floodlight, packed with young, massive blue stars. These stars burn hot and bright, making MOMZ-14 visible across 13.5 billion years. The galaxy must have converted gas into stars with incredible efficiency. This intense luminosity allowed JWST to spot it, even with gravitational lensing. The cosmic dawn wasn't a gentle flicker, it was an explosive burst of light. Galaxies like MOMZ-14 burst onto the stage with unexpected vigor. The early universe was far more conducive to rapid star and galaxy formation than we knew. The universe wasn't just waking up, it was kicking the door down. MOMZ-14 holds another surprise, its chemical makeup. Using JWST's spectrograph, astronomers found a surprisingly high amount of nitrogen. In the early universe, only hydrogen and helium existed. Heavier elements were forged in stars. Nitrogen is usually produced by intermediate mass stars, which live billions of years, or by rare, massive, fast-spinning stars. For MOMZ-14 to have so much nitrogen so early is a puzzle. The high nitrogen-to-carbon ratio suggests multiple generations of stars had already lived and died in just 280 million years. This is an incredibly short timescale for such chemical enrichment. MOMZ-14 was churning through stellar generations at a blistering pace. This level of chemical maturity was expected in galaxies billions of years older. Its chemical signature is similar to ancient globular clusters in our own Milky Way. The processes that built galaxies like ours were already in full swing at the universe's dawn. MOMZ-14 might be a typical example of how all great galaxies got their start. The discovery of MOMZ-14 is a disruptive event, forcing us to rethink our most cherished cosmological models. The old rulebook said galaxies form slowly, start small, and take ages to become complex. MOMZ-14 breaks every rule. Its existence at 280 million years after the Big Bang pushes back the timeline for galaxy formation by over 200 million years. This isn't a minor tweak, it's a rewrite of cosmic history. The standard Lambda CDM model struggles to explain a galaxy this big, bright, and evolved so soon. Theorists are scrambling for answers. Were the first stars even more massive? Did supermassive black holes form earlier? Do we need to rethink dark matter? MOMZ-14 tells us our current story is incomplete. This isn't a failure of science, it's its greatest strength. When discoveries contradict theory, new physics and deeper understanding emerge. MOMZ-14 is a beautiful problem, a mysterious messenger from the past. For scientists, there's no more exciting message. You have more to learn. MOMZ-14 is astonishing, but it's not alone. If it were a fluke, we might dismiss it, but JWST has found over 100 other bright, massive galaxy candidates from the universe's first 400 million years. The exception is becoming the rule. The cosmic dawn wasn't a sparse landscape, but a vibrant, bustling cosmos filled with active galaxies. This population of early bloomers was far more numerous than anyone predicted. JWST's power has revealed a rich ecosystem of galaxies that was there all along. This abundance helps solve the puzzle of cosmic reionization, the process that made the universe transparent to light. The discovery of so many bright star-forming galaxies shows they were powerful enough to light up the universe and end the cosmic dark ages. The conditions for forming large, complex structures were in place almost immediately. Galaxy formation was more efficient and rapid than we ever imagined. We're not just seeing the birth of a few galaxies, we're witnessing the birth of cosmic structure itself. Each new discovery helps us build a more complete picture of how everything began. The discovery of MOMZ-14 and its siblings is not an end, it's a spectacular new beginning. Each answer JWST provides unveils a dozen new questions. The journey to understand these cosmic pioneers is just starting. Astronomers will use JWST to study these galaxies in greater detail, mapping their structures and chemistry. Soon, the Nancy Grace Roman Space Telescope will join the quest, surveying thousands more early galaxies. We live in a privileged moment. For millennia, we wondered about our origins. Now, we can see them. MOMSI 14 has pulled back the curtain on the first act of the cosmic play. The universe is always more surprising and beautiful than we imagine. The quest continues, fueled by curiosity and the promise of even greater wonders. The story of the cosmos is still being written, and we have a front row seat.